Hey everybody, Mr. Cruz here to work on the study guide. I'm going to upload the key just after I'm done recording myself completing it. And I'm coming at you in probably the best audio you have heard from me yet. That is because while I was leaving school on Friday, I forgot to take home the splitter for my headphones. What that means is that for my particular computer, I have separate jacks for headphones and microphones. So I need that splitter to use both of these. Since I don't have it, they only work as headphones right now. Well, luckily, your teacher happens to have a great deal of audio recording equipment, so I grabbed this cardioid microphone and my music interface. This is an audio box USB interface, and just set up like that. I'm still have the headphones on because I can hear my own voice coming through the microphone, which is kind of important with one of these because if you have it set up wrong, like for example, if I turn the microphone way up, you can hear like everything that my mouth is doing, and it's super weird and uncomfortable. But fun fact, this is actually the type of microphone that you'd usually see in one of those ASMR videos where they make all the mouth sounds, because they're cardioid microphones, which means that they only work in one direction, so you can get like a nice and close up on it and you can hear everything, but you can't hear any other sounds in the room. Like right now, you might be able to hear me, but it's just the noise of my voice reverberating off of the room's walls. That helps delete a lot of unwanted sounds from around the room. So if you have like a loud air conditioner, it won't pick it up as well. It's also useful for recording loud sounds because they can usually handle very high air pressure, meaning very, very high volumes. So really loud stuff, like for instance, a guitar amp. It's really good for recording that. So just a little bit of audio file nerdery for you, for anyone else who's interested in sound equipment or voice recording or anything like that. I know I probably have a few students who are into recording music, or maybe voice acting is something that you're interested in. Just a few cool things to let you know about. Now let's talk about the thing that you actually came here for, the study guide. Let me pull that up. We're going to go through it question by question. I'm going to make the key and then upload it for you just afterwards. There's going to be a lot of cuts because I have to set this thing down to type. All right, now this is going to be kind of a speed run of this thing, so be prepared. But I'm going to try to explain my reasoning as much as I can as I go through. Some of it, though, is straight up just memorization, just word association. For instance, this first question asks, what type of bond is formed when two atoms share a pair of electrons? Well, that's covalent, because covalent is shared, and I just remember that. That's just in my brain forever. What type of atoms come together to form a covalent compound because they share electrons? Two nonmetals. How many electrons are shared in one covalent bond? Ah, yes, the most missed question on the quiz so far. Well, let's look at this diagram right here, and maybe that can tell us something. Because spoiler alert for question number 4, this is a covalent bond. I've got two nonmetals right here, and as you can see, I've got one electron from the hydrogen in each one of these bonds, and one from the carbon in each one. So everybody puts in one electron sort of into the collective pot, and that forms the covalent bond. So each one puts in one, which when you add it up means there's two in each covalent bond. So, 2 electrons in every covalent bond. This one wants us to describe the bond being shown here. Hey, we already know it's covalent and that the electrons are being shared. Boom, knocked out. All right, this next question asks us to write the formula based on the picture. Okay, all I gotta do here is just use the straight up picture to find the formula. Well, there's 1p and 3 BRs, so this is PBr3. All right, now we're asked to describe what happens to the electrons in the formation of the compound magnesium oxide. Well, magnesium is a metal and oxygen is a nonmetal, so that means we have an ionic bond, and ionic means that electrons are transferred. Oh, specifically, 2 electrons are transferred from the magnesium to the oxygen. How do I know? Because magnesium is in group 2, so there's 2 electrons, and oxygen is in group 16, which means he has 6, and he wants 2, so he can have 8. So those 2 on magnesium end up on oxygen. What type of chemical bonds involve the transfer of electrons between atoms? Ha! I've already described that. It's ionic. What is the chemical formula for the stable ionic compound formed between lithium and iodine? Well, let's draw that. Alright, so I got a lithium here. It's in group 1, so it has 1 electron. Iodine is in group 7, so it has 7 electrons. And it wants 8 of them. So lithium wants to get rid of its electrons because there's a full outer shell just underneath that one. It's easier to get rid of 1 than try to fill that shell up with 7 of them. So what he's going to do is he's going to give that electron to iodine right there. Yeah. And then iodine will have 8. Lithium will have its full outer shell now that that one's gone. So it just took one atom each to make that happen. So this is LiI. Also, make sure that you capitalize the I for iodine and make sure that it's lowercase for lithium. L, lowercase I, capital I. All right, what is the chemical formula of the resulting compound if calcium were mixed with chlorine? Well, let's draw that one out too. All right, so I've got a calcium and I've got a chlorine here. Calcium is in group 2, so it has 2 electrons. Chlorine is in group 7, so it has 7. So what's going to happen is chlorine wants an electron. Calcium wants to get rid of his electrons. So he throws them onto calcium, says, here, you take these. All right. So now calcium has another electron to get rid of. He really wants to get rid of it, but but chlorine is like, nah, man, I'm good. I got 8. I don't need your electrons. So calcium has to find someone else to pawn this off on, so he's going to find another chlorine is what he's going to do. Take a look. Boom, there's another one right there. Let's draw the electrons on it. All right, I made these electrons bigger for some reason. I don't know why. All right, so calcium's like, ooh, another chlorine. Let me just drop this electron right on there, and that chlorine's like, oh, yeah, thanks, man. I really needed that. I have 8 now. I'm happy. So now these guys both have 8. Calcium doesn't have 1. We could talk about charges all day long, but it's really only asking us to find the formula. So it's 1 Ca and 2 Cls, so that's CaCl2. All right, this next question is kind of complicated. It's really like 3 questions in one. Why does the compound sodium fluoride contain an ionic bond? What happens to the electrons, and why does it react at all? Well, okay, it looks complicated, but it's not that bad, I promise. Basically, it's asking us why ionic bonds happen. Why does sodium and fluorine come together? Why do they come together to form an ionic bond? Well, we know that every atom wants to have 8 electrons around the outside. They can do that by getting rid of them or taking some of them up. Sodium, for instance, if I just draw a sodium right here, I'll draw it real big. Sodium's got 1 electron. It'd be way easier to get rid of that 1 electron than to add another 7 to it. Fluorine has 7 electrons. And it'd be way easier for him to just add 1 and get 8 rather than pull off all 7 to get to the outer to get to the full shell underneath. So because sodium would rather get rid of an electron and fluorine would rather gain an electron, they transfer them in order to make that happen. So how do we use this information to concisely answer this question? Well, simply put, we can say that because each atom wants to gain a full outer shell, but each atom does not have a full outer shell, they transfer electrons in order to make that happen. All right, this next one just asks us to ID the types of compounds formed by each reaction here based on what the elements are. So if it's a metal and a nonmetal, it'll be ionic. If it's two nonmetals, it'll be covalent. So calcium and nitrogen, that's a metal and a nonmetal. That's ionic. Iodine and chlorine, two nonmetals. That's covalent. Phosphorus and nitrogen, two nonmetals. That's covalent. Potassium and sulfur, metal and a nonmetal. Ionic. Silicon and oxygen, metalloid and a nonmetal, which is still covalent. Yeah, you heard right. It has to have a metal in order to be ionic. Silver and phosphorus, that's a metal and a nonmetal. Ionic. All right, so how did I know that a formula represented a covalent compound? Because there were two nonmetals in it. We just talked about this. And how do I know that it's ionic? Because it's got a metal and a nonmetal. Label each property as either covalent or ionic. Low boiling point, that's going to be covalent. Forms molecules, that's a covalent compound. Soft and flexible, also a covalent compound. Conducts electricity, that's ionic. All right, so number 15 is kind of complicated, but I promise it's not as bad as it looks. It says Jane studies the properties of 4 ionic compounds. They're listed right here as shown in the table. So what can she conclude about the elemental compositions of ionic compounds? So all this stuff up here, let's put a pin in that for a second. Let's look right here at these two words, elemental compositions. When I ask you what the composition of a pizza is, what would you tell me? No, pineapple does not belong on a pizza. That's right, pepperoni and anchovies. So, you just told me what a pizza is made of. So when I say elemental composition, I mean what elements it's made of. And if we look in each of these, it shows the elements and their properties. Even if we don't have a periodic table and we can't figure out if sodium is a metal, well, it's shiny and conductive. That's a property of metals. Chlorine is a gas and non-conductive. Two things common for nonmetals. Let's look here. Shiny and conductive, that's a metal. Liquid, non-conductive, that's a non-metal. Calcium and sulfur both have properties of a metal and a non-metal. Magnesium and oxygen, metal and a non-metal. So we can say that ionic compounds are composed of a metal and a non-metal. All right, for this one, all we got to do is use the prefix chart up here, and if we remember the rules from our flowchart, those as well, to name a few compounds or find the formulas based on some names. So let's go through that very quickly. Diphosphorus pentoxide, well, di means 2 and penta means 5, so this is P2O5. Correct name of SO3, well, I'm just going to write out sulfur and oxygen, then change the second element to IDE for the N, so that'd be sulfur oxide. Then, because there's no metal, I use prefixes, so this is going to be sulfur trioxide. This next one wants us to write the formula for carbon tetrafluoride. Well, we know we're going to have one carbon, and then when it comes to, we know we're going to have one carbon, and then tetra means 4, fluoride would be fluorine, so this is going to be 4 Fs, so CF4. The next one asks us to figure out what calcium and oxygen are going to... The next one asks us to figure out what the formula of the compound that results from calcium and oxygen being mixed together is going to be. Basically, what's the formula for calcium oxide? So, to figure that out, I just drew these out right here. I've got one calcium and one oxygen, and as you can see, calcium has 2 electrons. Oxygen wants 2 electrons because he has 6. He needs 2 to get 8. They go right here and right there, and when we're done, it took 1 atom each to do that, so it's CaO. All right, this one's pretty simple. We've got 2 nonmetals, so we're going to use prefixes. Nitrogen, that's 2, so dinitrogen, and then 4 oxygens, so tetroxide. Dinitrogen tetroxide.